So this is exercise related to reversible reactions. Reversible reaction, we can change the position of equilibrium by either changing the concentration or changing a temperature, depends on whether a reaction is endo or exo, or we can also change the pressure. So three ways the equilibrium can be shifted. The equation for stage of a contact process, as you can see, 2SO2 plus O2 gives to SO3. The percentage of a sulfur trioxide, you can use your mic to state the answer, or you can also use the chat. What is convenient, you can use that. So the percentage of a sulfur trioxide, this is sulfur trioxide as a product and sulfur dioxide is a reactant. How does the percentage of sulfur trioxide in equilibrium mixture vary with temperature? Circle the correct answer. So use screen annotation, circle the correct answer. How this percentage of sulfur trioxide is changing? Use the screen annotation. As we are increasing a temperature, what happens? You can simply use the graph. This graph is there, so you can simply use this graph to state what happened to percentage of sulfur trioxide. You can use the screen annotation to state the answer. So you can clearly see from this graph, as we are increasing a temperature, like here we have high temperature, here we have low temperature. And percentage of sulfur trioxide, this will be low and this will be high. So as the temperature is getting higher, the values of percentage of sulfur trioxide is decreasing. So if the value of sulfur trioxide is decreasing, what it shows when increase in temperature reduces the percentage of a product, it means the forward reaction is exothermic. Means this reaction is exothermic reaction as the amount of a product is decreasing as we increase the temperature. So the reactants will have high energy and the product will have low energy. Yes, Mohammed, if you have any question?
Yes, sir. Sir, this graph shows that it's exothermic.
Yeah, this using this graph, we can say it is an exothermic because when we are increasing a temperature, the amount of the product is decreasing or equilibrium is shifted towards left hand side. So whenever you increase the temperature and you observe the equilibrium has shifted towards the left hand side, it means the reaction, forward reaction is exo. So this also showed. If it was an endothermic reaction, like if this reaction was an endothermic, then what should be the shape of the graph? That when you're increasing a temperature, the percentage should increase. If this was a graph, it means this is an endothermic reaction forward, that increasing a temperature, shifting the equilibrium towards right, or the percentage is increasing. But because it's an exothermic reaction, so increase in temperature reduce the percentage. The next question is the forward reaction in equilibrium is exothermic or endothermic? Give a reason for your choice. So 1 mark, we will mention it is exothermic. So when you write exothermic, you will score 1 mark. The second mark is for reason. So what will be the reason? You will mention as we increase the temperature, the percentage of sulfur trioxide is decreasing, which shows the equilibrium has shifted towards the left hand side. So whenever we increase the temperature and we observe the equilibrium or the balance is shifted towards the left hand side, it means the reaction is exothermic. And if we increase the temperature and equilibrium or the balance shifted towards the right hand side, it means the reaction will be endothermic. So we can say the yield is directly proportional to temperature in endo and inversely. Yes, you can mention that as well. Like yield increase or amount of product increases in when we increase the temperature in endo, and it will decrease for exo. In question 2, carbonyl chloride, which is COCl2, is a colorless gas and it is made by the following reaction. COCl2, when we cool or we decrease the temperature, equilibrium is shifted towards the right. And when we increase the temperature, equilibrium is shifted towards left. Can you identify this change? Because it's written when we cool down, we get more product. Like when we reduce the temperature, we get more product. When we increase the temperature, the backward reaction happen or we get less product. So which reaction, what is about the forward reaction?
So, Mr.
Exo,
Exothermic.
the forward reaction is exothermic because exothermic reaction prefer a low temperature or reducing a temperature to get more product. That will be the question. Like later in this one, you have to answer. Now, when the pressure and equilibrium mixture is decreased, now what is the effect of the pressure? Remember, when we increase pressure, equilibrium or the balance will shift towards side where we have less moles or less particles of the gas. And if we decrease pressure, the balance or equilibrium will shift towards side where we have more particles of the gas. So when we check the number of the particle here, 1 and 1, so there are 2 particles. And here we have only 1. So total, what we are doing in the question, they said when the pressure in the equilibrium mixture is decreased, we reduce the pressure. So if I decrease the pressure, balance will shift towards side where number of the moles are more. So means it will shift towards the left hand side. How does the concentration of 3 chemical changes? If the balance or equilibrium will shift towards the left hand side. So it means the amount of the reactant will increase and amount of the product will decrease. So what happened to the concentration or amount of CO and Cl2? What will happen? Increase or decrease?
Decrease.
Increase.
Increase. Because the balance has shifted towards the left hand side. When the pressure in the equilibrium mixture is decreased, whenever we decrease the pressure, it will always shift the equilibrium towards side where we have more particles. So which side we have more particles? In the reactant side, we have more particles. In the product side, we have less particles. So the balance or equilibrium shifted towards left. So whenever a balance or equilibrium shifted towards left, the percentage of the reactant or amount of the reactant will increase and the percentage of the product or amount of product will decrease. So the reactant CO and Cl2, the amount will increase. And what happened to COCl2? That amount will decrease. And the second part, why the equilibrium has shifted? Because when we decrease the pressure, it will, you just have to write here, it shift towards side of more particles or more moles. So favor the side of more particle. So explain why the position of equilibrium move towards left. Because decrease in pressure will favor the side of more particles. And if they ask the equilibrium shifted towards right, in that case, if we increase the pressure, so we'll also mention it will shift towards side of less particles or favor the side of less particles. Okay. Moving on to the next part, use the information given with the equation. Is the forward reaction exo and endo, and give a reason. So as you can see, when we are decreasing a temperature, we are getting more product. When we are increasing a temperature, because heat is given at the backward arrow and the forward arrow is for cool. Cool means we decrease temperature and heat means we increase temperature. So when we are decreasing a temperature, we are getting more product. So whenever we decrease the temperature and we get more product, it means the forward reaction is exothermic. So answer, you will mention the forward reaction is exothermic because it is favored by low temperature or shift the equilibrium towards right when the temperature is low. So exothermic reactions always prefer low temperature to shift the equilibrium towards right. So one is for exo and one mark is because it shifts equilibrium or the balance towards the right when the temperature decrease or when it cool down. In question 3, ammonia is manufactured by a Haber's process and the forward reaction is exothermic. So if this reaction is exothermic, if I increase the temperature, where the balance will shift? Equilibrium will shift.
Towards the left.
So it will shift toward the left. So whenever we increase the temperature, for exothermic, it shifts toward left. But if we decrease the temperature, it will shift towards the right-hand side. Name a raw material from which we have nitrogen and hydrogen. Normally, nitrogen, because it's present about 78% of air contain nitrogen. So we have nitrogen from air. And how we can get hydrogen? We can use by electrolysis of aqueous solutions. And NH3 is ammonia. So from where we get nitrogen? Nitrogen we can get from air. Yeah, platinum was used as a catalyst normally, but now because iron is used as it is a cheap catalyst compared to that of platinum. Platinum is expensive, so it increases the cost. Hydrogen, how we can get from aqueous solutions, electrolysis. So name a catalyst used in
Sure,
this process.
it
Yes,
can be also by cracking.
yeah, also by cracking of a hydrocarbon. About the source of the nitrogen and hydrogen, we'll discuss in topic 10, which is about air and water. What is the most important use of ammonia? Where we use this ammonia? Ammonia is mainly used as a fertilizer or to make nitric acid. So it is used as a fertilizer or for manufacture of a nitric acid. About the cracking of alkane, we will discuss in organic chemistry. Yes, you can write platinum is acceptable as well. But the correct one, like commonly iron is used rather than platinum was used earlier, but now it's iron as it is cheap. Again, you can see when we are increasing a temperature, the percentage of ammonia is decreasing. So this confirms that this reaction is exothermic. Explain the term equilibrium. So definition of equilibrium, a 2-mark question. So what is the definition of equilibrium? 1 mark when you will mention when rate of forward is equal to rate of backward reaction. And the second mark that there is no change in concentration and of reactant or product. When the amount of the reactant product does not change at all and the rates are also same, we call that, but don't say equal. Don't say the concentrations will be equal or don't say amount will be equal. That is the wrong definition. How does the percentage of ammonia vary with temperature? So what happened to amount of ammonia with temperature? Yeah, that's right. So it is decreasing. So this is always a 2-mark definition. Rate of forward equals to rate of backward. And second mark, there is no change in concentration of reactant or product. But don't say their concentrations are equal. That will be wrong. In part C, we have to sketch a graph how the percentage of ammonia vary with the pressure. So if I increase the pressure, where the equilibrium will shift, in this case, so we
Shift
have,
towards the right.
right, because here 1 and 3, so total 4, and there total 2. Whenever we increase the pressure, equilibrium will shift towards side where we have less moles. or less particle. So in this case, it will shift toward the right hand side, or the percentage of the ammonia will increase. So when we want to sketch a graph, you will mention, show in this manner and explain why the graph has this shape. So you will mention increase in pressure favor the side of less particles, or in this case, it will shift towards the right hand side. So increasing pressure favor the side of less moles, less molecule, and in this case, it will shift towards the right hand side.